So yeah, this is a talk which I would like to share a bit of new work that we are developing in the Center for Change and Complexity in Learning in University of South Australia. And it's called the AI Learning Lab. And basically the idea behind this learning lab is to design, develop and explore AI learning experiences. And the main reason for that is that, of course, AI is booming, but also the whole digital transformation that we are currently going under means that the way we are relating to information and how we create and treat information is changing, and AI is having a great deal of influence on all of that. And I think it's important that within education, we make sure that our teachers and students grow up with this change. And currently, at the moment, especially in primary and secondary education, there's not a lot of AI going on, and most of the AI that's being used is sort of done to people. It's AI working in the background, providing people with information that they can either use or ignore. But what we would like to do is to try and see if we can use AI to create this learning experience and offer a space where kids can work and learn together with AI and potentially also take ownership over AI. By that, I mean that they can create their own AI solutions that match particular questions or problems that they may have. So basically what we would like to do is to develop AI that the students can use to follow their own imagination. So the aim is to have kids play and learn with AI, and further on to see if they can also develop AI themselves by offering some kind of AI sandpit, like we have in the regular playground as well. So through this lab environment, we would like to promote the development of the computational thinking skills. Now, I'm sure you have been discussing these the last couple of days quite extensively. But part of that is also to develop teamwork skills, because a lot of the work that we do is, of course, happening in teams, networks, and communities. And part of that, I think you need to be able to solve problems together, but also have co-design skills and things like that. Part of the experience in the AI Learning Lab is also for kids to, through play, understand and learn the capabilities of AI. And through their engagement with AI, they will also therefore then be exposed to critical thinking, but also to think ethically about the AI that they're using or they might be designing themselves. So it's not just about utilizing AI, but it's also through engaging with AI, understanding what AI is capable of, what are its dangers, what are its potentials, and of course, how can we make ethical use and safe use, if you like, of AI. Together in the network sort of approach, I think it's very important also that the kids understand sort of these hybrid human AI partnerships. So what we really would like to promote is ways in which children or kids work together with AI to solve particular problems. So again, it's trying to understand how we can experience, if you like, human AI teaming or, these partnerships. And therefore also develop a sort of a fluid agency, if you like, to operate in a world that is populated with intelligent human and non-human actors. And that's, to me, really where we are going with this society. So basically, what does it consist of? The Learning Lab consists of several components, and it's our aim to grow this over time. So basically, within the Learning Lab on the left side, you can see that we are offering challenges. These are the lessons, but they're sort of treated as challenges. And through these challenges, the kids can engage with the AI, and that's also done lots through gaming and simulation. So through simulation and play, kids can really sort of understand sort of what they can do, what is possible within this environment, and start to think critically about what they can achieve. On the right side, you have two other components, which is the leaderboard, which is one way for the kids to understand where they are going, what have they achieved, but also to see if new opportunities or new goals have been unlocked based on their achievements. And there is another component that's more for the teachers. It provides them a dashboard, like to present all kinds of learning analytics, to see what's going on and what particular kids have been doing. But also it provides further resources, lesson materials, manuals, and things you might need to run the Learning Lab. And there will be a teacher community or a teacher network where teachers can share their experiences, upload new lessons that they have developed according with the challenges that are already there. and of course build learning and other kinds of experience with their peers to further enriching, if you like, the playground. Now, this learning lab is not just entirely virtual. The main idea is to have instruments that the kids can play with physically in the classroom and through simulation, therefore enter then in the more virtual world. And that interaction, I think, is quite interesting as well. So the lab comes with a Pelican case, basically, and in the Pelican case, you will have the equipment that you need for the AI, which is mostly at this stage done through computer vision. So there will be a camera, there will be a hardware device like a NUC, an Intel NUC we're using at the moment. There will be the play equipment, sort of like the Fischer technique or the Lego, which is part of the lessons that we are developing at the moment. And a screen that will be optional. Most schools, classrooms already have a screen, so you basically just connect the screen up to the computer and start playing, if you like. So what I would like to share with you today is some of our design thinking behind building this learning lab, and that'll be done through going through the first sort of challenge that we have, or that we are working on, basically, and that's all about entertaining the kids with challenges to try and explore life on Mars. And basically that will be done through working with the toys that are part of the Pelican case and build a real Mars rover, but also, of course, build that in such a way that it can be used through simulation on Mars itself. So there will be a way of trying to make something on Earth that needs to work on another planet. And that's, I think, already quite an interesting challenge for AI to be used. So we will be going through a set of complex problem solving steps, which is all about understanding sort of, okay, what is the task definition? Let the kids sort of research the particular problem space and do some brainstorming, then come up with certain design ideas, start implementing and testing it, and then use the Mars rover, if you like, to start analyzing and reviewing Mars itself. And in the drawings below, you can see the same thing. It starts with understanding your home base, understanding sort of the materials that you have to build with, and then you can go through the simulation to Mars, and you can actually start to explore and look up existing Mars rovers, sort of walk around and see how they function and what they can be doing. Also, there will be an opportunity for children to design their own Mars rovers. And my idea is that we will have a bit of a Mars rover parking lot so that you can actually see what other kids have been building and use that as inspiration for your own designs as well. There will be a test track where the kids can test sort of the integrity of the Mars rover and see if it does function according to a set of criteria that are part of the challenge. They can have a bit of a race, similar maybe a bit like the Mario Kart, and sort of, you know, race each other and see who will be the winner in the end. And of course, they will be starting to drive around on Mars and explore Mars itself to detect or explore to what extent life is possible and if we can build a particular city on Mars. Now, to start defining the task and setting the scene, in the classroom, the teacher will provide some background information, set the ground rules for the challenge, as well as there will be a little video from Mike Seibert. He used to be, or he is, I think, still a consultant working for NASA, and he has been designing one of the first Mars rovers and drove this one on Mars itself. So he's really introducing the kids into the challenges that they were confronted by when they were designing their own Mars rover. And he sort of highlights a particular sort of design choices and explains sort of the thinking behind it, so that the kids already start to think about what a Mars rover should look like and how it sort of works in the Martian environment. After that, when the kids are ready, they can then start to use the AI component itself. And there are three forms of support that our AI solution currently offers. First of all, it provides feedback, and it helps the kids to understand what are the individual building bricks that can be used to design or build the Mars rover. And that's a way of understanding the capability of the pieces that you are working with. As soon as that's done, they can start building their own rover or follow the design steps that are part of the Mars rover that they are working on. And there the AI will provide them with support, by helping them thinking through how you can actually design the rover that you're building. And as soon as that's done, they can drive on Mars in the simulation, and that's where they can then start to explore Mars and do data collection, and of course also then start to use AI to analyze the data, especially when we're talking about big data sets and things like that. So again, it's a nice way of exploring the potential of AI and how you can use AI to actually achieve something, but also to help you analyze and interpret particular forms of data. So at the first stage, when we're looking at AI feedback, it's all about identifying the individual building blocks and understand what they are capable of. So the AI component, it's mostly through the camera and the computer, of course. It looks at the desk that the kids are using to build their rover. And basically, while the AI is constantly looking, it tries to identify the little individual pieces, the building bricks, if you like, that are on the desk. And it will present them with information about what it is about. So it will put a bounding box around the pieces that it has identified. And then on the right-hand side, it provides further information about what that piece is about. It provides a little bit of text, where it is used and how it can be used in the context of their building. And in the next slide, we see one of the kids in the group who's starting to play around with that. So you can see here on the picture on the left side, you can see that the AI solution is not necessarily that intrusive. So basically you got the camera on a tripod. I'm not quite sure if you can see my mouse, but I hope you do. And the little computer is sort of lying on the desk as well. Now, the only big thing, of course, here is the big computer screen or the TV screen, but you do not necessarily need such a large screen. But for this particular experimental setup and for us itself, it was quite handy to use. But the kids were not necessarily offended by the technology that is part on the table. They simply easily forget about it, and they interact with the AI directly by putting stuff on the table or taking stuff from the table away again. And in this example, you can see the boy is putting something on the table and the AI is starting to look at it. And it identifies the object in the picture on the right by putting a yellow box around it and presenting the information, what it's all about. Now, in this particular case, it's a wheel. And we, of course, all know what a wheel is and what it does. But still, it's the achievement that we're after here. So I would like to present you a small video. The text you won't be able to hear, but it's more about the gestures. So here you can see how the kids together are putting pieces on the table and how the AI is picking up what these pieces are and is interacting with them at the same time. I hope that the play button works for you guys as well.
Is there anyone we can so red is yellow? What is yellow? Is there any
So the kids are putting stuff on the table and they're discussing with each other sort of what they're seeing, and they're trying to identify the particular pieces that are there. And this process is really there to help them identify the pieces that they need for their part of the Mars rover design that they're after at the moment. So at this stage, the AI helps them to recognize particular pieces that they might need. And they can access additional information on what they can do with these particular pieces. Now, in this example, we were working with the Fisher technique, but in the next example, we are using the same AI solution, but now we're using the Lego Mindstorm set, the EV3 sets that most of the schools already have. And we thought that would be quite a nice idea as well to expand a little bit on what we can do and provide the children with the opportunity to build a Mars rover based on the Lego sets that are already present in the school. And at this screen, what you see here is that the blue screen in the background, that's again what you will see through the computer camera. And that screen is always active. So if you put Lego pieces on the blue screen or on the blue table, basically, that's what it is. it puts a bounding box as soon as it identifies a particular Lego piece, and it highlights the corresponding card in what we call the conveyor belt here below. So this is a way of selecting or getting support in selecting the pieces that you need for your particular design build. And the other thing is in the insert here, you can see the model or the component of the rover that you are achieving here. And this is, at this point, it's the chassis. And what you can see here is that the AI picks up the pieces on the table, but at the same time, it identifies the selected pieces in the model that you are building. And this 3D model, you can zoom in, you can rotate, so you can really try and identify through the model what it is that you're trying to build. And if you can't find the pieces yourself, you can put the pieces on the table and the AI will give you hints and helps you to achieve selecting the right pieces that you need for your particular build. And if you have other pieces lying here, they will light up as well as soon as you click on the boxes, or we can do that automatically as well. So then you can actually see everything that is part of the component that you build will just simply light up blue, but they may not be connected yet, of course. Part of the information that the AI also can provide is to show little videos on how you can connect particular pieces together, especially if it's about tiny little pieces. And all this kind of support is optional. So the kids can decide to use and work with the 3D simulation here or the model, zoom in, zoom out, and try to do it together. And they can call on the AI by putting pieces on the table to try and identify the pieces that they need or learn a bit more about the pieces that they're after. Then when we move on to the building stage, we can sort of see here that this is the Mars rover that they're achieving to build. And you can see this, these are, if you do recognize it, these are the pieces from the EV3 Mindstorm sets. And it has the building blocks as well as the motors and the sensors and the computer brick. And that'll be interesting as well, because further on they can then start to program these sensors and make use of them on Mars itself. But when they start to build, it's not time for the sensors yet. They first need to select which components they are working on. And they can work on multiple components, but not at the same time. So you can go back to a particular component, or you can start with a new one, and the tool will simply memorize sort of where you were based on the component that you have selected. But in this case, we're still working on the chassis, for example. And again, here, it helps you to identify the pieces, and you can click on the pieces that you need. And as soon as you start putting pieces together, it tracks what you are connecting. And if they are connecting, the connecting pieces that it sees on the table are lighting up in blue. So you can actually follow, if you like, a building path through the model that you are working on. And if you put other pieces on the table, it might be that this thing lights up, you know, this sort of rectangular piece part of the box. Now, that's not necessarily what you are working on, so you might want to put that out of the frame again so that it's not blue anymore. But this way, you can still use the AI to put individual Lego pieces on the table and sort of see where they fit, should you need to. I mean, if you zoom in and you can already identify the pieces you need, you can build it, and the AI will simply try to keep track on how you have connected the particular pieces. Now, there are two things that you can do here. You can either identify yourself sort of the next piece that you need, or you can ask the AI to highlight the next piece if you can't find it. And then in the screen, you will sort of see lighting up in red, what is the expected next piece. And then you can, of course, select through the pieces that you have, see if see if the AI highlights it in blue so that you know it's the right one, and then you can connect it. And if that doesn't work, you can still watch the video again to see how you can actually do that. But I think in most cases, people will probably quite know what it's all about. In this little box here, there might be some suggestions also if there are sort of more hidden pieces, because sometimes pieces are obscured, and it will provide further information on how to do that. Now, as soon as you think that you're done with your rover, you can click on the button to scan your entire rover, and the AI tool will provide you with a little bit of information on how you can scan your own rover. And as soon as it detects all the pieces that are there and in place, all the components are done, you can then visit Mars with your own Mars rover, basically. Now, we are working on 2 versions here. The one that I've shown you is the one that sort of always builds up to the particular Mars rover, which is more like a guided AI solution. But in the semi-guided solution, the kids can simply start to identify certain choices that they make, and then they can build their own Mars rover version, and then they can have it scanned here, and then the AI will pick it up and put it into a simulation on Mars as well. And that's how you can then start to drive your own Mars rover design, whether it has 6 wheels or 3 wheels or 2 wheels, whatever you think is possible. And each rover that the kids are designing will become part of that parking lot that I talked about in the beginning. And this way, the AI can learn from the kids about different designs for Mars rovers, and the kids, of course, can study the Mars rover parking lot to identify different designs as well that might guide their own thinking. Turning back to the Fisher technique, this is a different approach here, and here again the AI will pick up the pieces and give the kids information on how to assemble it. And I'll try and show that in this little video. So here you see the boy is trying to identify the piece, learn from it, and then put it on the wheel in this particular case, because that's where it needs to go. So again, he's just working on a component that is part of the Mars rover that they're trying to do, and through interacting with the AI, it gets the right sort of information, and together they achieve the task. Now, with the Fisher technique, the scanning is done a little bit differently. So basically, there are 5 stages of completion, and each stage is about 20% of the final build. And each stage, and here I have 3 examples, it consists of a certain amount of, like the 20% of finishing their stage. And again, they can explore this model, they can look at it, what they sort of need. And when they think it's completed, they can hold it in front of the camera and they can sort of turn it around. And as soon as the AI identifies it, it puts a box around it and it will say like, okay, the first 20% is complete. You can now move on to the next stage. And so you go to the next stage and the next stage until you're finished. So here, for example, you can see stage 5, and on the computer screen here, top right, you can see that the camera or the AI has detected the rover, and it identifies that it's sort of a stage 5 because it has the wheels, and then it sort of recognizes and confirms that you're done, which means that you can then progress to the final stage of the challenge, and that's the exploration itself. And this is where you can get a few instructions. You can either drive your rover through a keyboard, or you can have a controller or a joystick or whatever. But the point is that you can then start driving your own rover on Mars and start to have a look around. And this is like a free sort of exploration. You can just drive around, have a look, and see what you think. And after you've done that, you will start to realize that you don't get a lot of feedback. You know, you're just simply driving, but you're not necessarily sure where you are, what you are doing, and what to achieve. So after you've done your testing, the challenge then will be to think about, okay, well, how can we actually gather and collect information about Mars itself? And this is where the sensors that I mentioned at the beginning of the presentation start to come in. And especially with the Lego set, which is why we chose the Mindstorms, is quite nice because it comes with certain sensors. So there is a gyro sensor, for example, and that can be used on the rover, you know, to start mapping the terrain. So you can actually start getting coordinates, and therefore you can get sort of like an inlay on your simulation that you can sort of see, okay, this is the terrain that I have started to map. And this way you know where you are, and you get sort of reference points and things like that. So that'll be a great way to then start to understand sort of where you are on Mars and where you might like to collect additional data. With the motors and the Lego pieces, you can also build a robot arm or a kind of a shovel or whatever, and that you can use that to collect dirt or soil, or do sample scratching at the surface of Mars, which can then of course be analyzed as well. And you can collect further environmental data. And with these sensors, you need to think about how to program these sensors, how to link them all up. So I think, like I think it was discussed yesterday with the SNAP programming and things like that. I think it's quite nice within the Lego environment. You can also start to think about, what are the essential programming skills that you might need? How can I make the certain radar sensors go round and round? How can I make the shovel go up and down? And how do I make sure it pushes the samples into the bucket and stuff like that? So there's a lot of programming that you can do to complete your exploration and driving around. And we're thinking about how we can also then start to use AI to provide AI for the kids to then start to analyzing or do pattern detection in the data that they have collected on Mars, and make further decisions about where they might like to start a city or things like that. So basically what we're thinking about is to think about all kinds of ways through which we can engage and expose kids and have them using AI to solve that particular problem or the challenge that they are confronted with. So the idea is that they can, of course, work as a group and try to build their own Mars rover. But if they need help and they want to have the AI become a team partner, they can use the AI component to put Lego pieces or fish technique pieces there and get there for the suggestions that you would otherwise might get from another peer student. So I think we're trying to emulate sort of the questions you might ask to your peer students, and see in what kind of way the AI will provide similar feedback and provide confirmation that things are done well and they match up with where you are. So the whole idea is of course to not use the typical Lego manuals to start building your rovers. Now I'll tell a little bit, I'm not quite sure if we have time, but I think we do, to tell a little bit more about the research environment or the research site that we are putting together to then study how these rovers and lessons are being used in the classroom. And basically what we're thinking of is to have several groups in the classroom, or we focus on one group, but basically to have the kids experience the challenges as a learning experience and observe how they are doing it, collect data and try to develop learning analytics to provide feedback about the learning challenge that they are going through, as well as therefore use that to augment the learning experience. So that's basically the cycle that we are going through. And we have two ways of collecting the data: through the AI rover builder, or the one that is looking at the desk. You can see the camera here and the Lego pieces. This will collect all kinds of data about the problems that they are solving. It's understanding how they go through the problem solving stages through building the rover itself. It will detect, of course, how many kids are actually engaged with it. And also it will understand or collect data on how many times throughout the session the AI component has been used. Now, a second data collection that we will be using is more like the group dynamics. And this is looking at how the group is actually working together as a group and together with the AI to solve the particular problem. So here we try to collect data about who is actually talking or connecting or interacting with whom, and to what extent do they integrate the AI components as part of that. Through video as well as audio, we can do analysis on the interaction itself, and are they actually talking about the challenge that they are working on, and through that we try to measure their content creation and problem solving stages. So we try to use the data in a way to get a sense of, can we measure the problem solving steps that they are going through, and can we use that data to either inform the teacher or provide additional reports afterwards to see how well the group was faring to get through the Mars rover design. So basically it's a bit like an ongoing cycle. you know, we provide certain learning experience by offering them particular learning challenges. We try to collect all kinds of data and research how we can use the data to start to measure, if you like, certain steps in the problem solving and teamwork phases, and see how we can use that data to then start to augment their learning experience. So basically it comes down to, you know, translating or creating the lesson plan to offer certain experiences and try to map or match, you know, in-class observation and see if expected behavior is matching up with the certain detected behavior, and use that information to then improve the lesson or augment the learning experience. So as a whole, this will present you with a whole lot of research questions. So basically the research program that we are sort of unfolding around this is to understand human AI networking, collaborative problem solving with AI and without AI, if you like, understand the development of computational thinking skills, particularly in that aspect of designing the sensors and computing or programming the sensors so that it collects the kind of data that it does. Understanding how the kids actually accept working with the AI and do they trust the AI, but through working with the AI, they will also see that the AI is making mistakes as well. So I think it's quite nice to understand sort of why that's the case. And of course, through that, understand how AI works and what its capabilities are and what it might need to improve. And on the classroom and the teaching side, it's also about understanding how we can actually adopt AI in classroom practice, research and observe, if you like, teacher values and teacher beliefs, as well as particular teacher professional development needs that they may have. So basically, that's what I would like to share with you today on this AI Learning Lab project that we are working on. And, you know, do reach out to me if you have questions or if you would like to be involved or see if we can do certain testing in other countries. By all means, just drop me an email and we can see the conversation.
Thank you so much, Professor de Laat, for sharing this very interesting developmental ideas regarding the AI Learning Lab. It really looks promising, even if there are actually in the near future even going more and more missions to Mars, because that's really where everybody of us thinks wants to have a sneak peek on. Actually, I will, but I hope so. But I'm too old for that, so that will not be the case. But for sure, we'll have several questions for you from the audience, maybe online or maybe on site. So if there are any questions to Professor Laat, please raise hand. Yes, Daniel.
What kind of tool did you use to create the 3D simulation of the Mars rover?
The simulation? That's done in the Unity environment. Okay. So, but basically, this project is a collaboration between our university, Intel, and MELT-CX. And MELT-CX is an AI developers company, and they work a lot through computer vision. So most of the AI development is done through them, as well as the development of the 3D simulations. And MELT-CX is part of the Acer group, which is of course big in the gaming industry. And that's, I think, why we have chosen the Unity environment to start creating the simulation of the Martian environment.
Yeah, okay, thank you very much. Are there any other questions here in the room?